Okay, the next type we have here is a metallic bond. And metallic bonds are the freaky ones. As a matter of fact, for the longest time, they didn't even call this a true chemical bond, but then they realized, hey, you know, technically it fits our rules here when we say, hey, this is a bond. So it's sharing or transferring electrons, and in that case, the metallic bonds, they fit that. So metallic bonds are really, really weird, and they occur when metals give up electrons, forming this sea of electrons. So let me explain this. You get 3 or 4 gold atoms together, or we can get enough that we can see. You get a big chunk of gold, and the valence electrons, they just travel, just the valence electrons, they just travel from atom to atom to atom. And bonding is when you transfer electrons or you share electrons, and that's exactly what they're doing. And what it means is you have this atom of gold, and it's got its core electrons, but the valence electrons, oh my gosh, they're just partying all over the place. It's like the valence electrons go to the party with one atom and leave the party with another atom. So what you end up having is these nuclei of all of these atoms, and they're just in this vast, they call it a sea of electrons. And you know, they've got that in quotation marks because that's really the way you pick up a chemistry book and you're going to see, oh yeah, it says sea of electrons there. So it does some weird stuff. It gives it some really weird properties. Because you have these partying electrons just traveling around all over the place, you get some strange properties. So these are positively charged atoms, and they're bonded through their attraction to the negatively charged electrons. They're all actually end up being neutral because they're sharing these electrons freely. They're just roaming around all over the place. What's amazing, though, is it gives it the ability to conduct electricity, because electricity is just moving electrons. That's all it is. We're just moving electrons. Typically, they're moving in one direction, and we tap into that, and we use that motion of electrons to, light up a light bulb or run our phones or whatever it is we do. But we have some really interesting things going on, and you'll spend more time on bonding when you get into your chemistry classes. So you see a lovely, pretty picture here. And you see where it just popped up the free electrons. The valence electrons, they're just roaming everywhere, all over the place. There's the metal cation, because at a moment, or just momentarily, it's going to be down an electron, or because it's lost an electron. They just randomly move all over the place. Okay, so this is what you need to know about the bonds: ionic, covalent, metallic. So the first thing is, in ionic bonds, the electrons are transferred. In the bond is from a metal to a nonmetal, or between a metal and a nonmetal. It's typically a crystal, which is kind of interesting. If we go back in the chemistry storeroom and we pull out the ionic compounds, they're all in little bitty tiny crystals. Now you can powder them, you can crush them down, but if you typically just kind of grow them in solution, which is what a lot of times how we make them, they form crystals. If you like any of the gemstones, those are mostly ionic compounds. They're a lot tougher a lot of times than what we have in the lab back in the storeroom. They are only conductive when, it says when they're aqueous. Aqua should sound like water to you. That means when you dissolve the ionic compounds in water, they conduct electricity. Think sodium chloride, salt. They have a really high melting point. And the best example would be sodium chloride. You guys might have heard of things like Epsom salts, MgSO4, MgO, magnesium oxide, copper sulfate. You can have all sorts of things, but it's always going to be a metal bonded to some nonmetals. And again, remember, you can pause this whenever you need to. In covalent bonds, the electrons are shared. It's always a nonmetal bonded to a nonmetal. These are typically solids, liquids, and gases at room temperature. Most of the time, they're liquids or gases at room temperature. There are some solids, but they usually have pretty low melting points, so they're easy to change into a liquid here. They don't conduct electricity at all, and they have really low melting points. Think sugar. If you try to melt salt, you guys have never seen melted salt. And I don't mean dissolving it in water. That's not the same thing. Melting means you heat it up so that it changes to a liquid. Dissolving means that you put it in water. Sugar, if you try and melt sugar on the stove, it melts really quickly, and you better be careful because you can burn it and stink up the house pretty easily too. Sugar is a covalent bond. C6H12O6, carbon, hydrogen, oxygen, those are all nonmetals. Examples: water, oxygen, carbon dioxide blow out and you've got carbon dioxide gas. Sugar, glucose, those are all examples of covalent compounds. And then the last one is metallic. The electrons are just swarming all over the place. They're the partying electrons. They're positive nuclei and a sea of electrons there. The bond is between a metal and a metal. Now, these things have some really interesting characteristics, which I think you guys probably talked about before. I think in the notes earlier. Metals, they're ductile. That means they can be pulled into a thin wire. And they don't break easily, because the bonds between the metal atoms are strong, because they're swarming. Those electrons are swarming. It's like if you were to hold hands with someone, only instead of holding just 2 hands together, now you're going to hold 4. Or maybe if you were an alien and you had 5 hands, you could hold all 5 hands. So it's really, really strong. The more hands you're holding, the stronger the bond is. They're ductile. They're shiny because the light reflects off all those moving electrons pretty easily. So you have really some interesting characteristics. They are crazy conductive. They really conduct electricity. Their melting points that is wrong on the paper. It should say high. The metallic bonds have really high melting points. So you guys fix that on your paper. It should say a high melting point. And then examples: copper, aluminum, gold, silver, and even way over on the other side of the table, way over on the left, the things that we don't usually think of as metals: calcium, potassium, sodium, those are all metals too.